Hello, this is your special education virtual content specialist with the 6th grade math lesson for June 14th. This lesson, like all other lessons, can be found on TeachHub, and we provide the title, the focus question, and the learning objectives, including the standards and objectives for each of those lessons. Additionally, we provide guidance for using this resource, including instructional and technology guidance, implementation guidance for each slide in the lesson, guidance for summarizing, guidance for assessment during instruction, and general methods of engaging students with disabilities and multilingual learners. 6th graders are continuing to work on Unit 8, Data Sets and Distribution. Day 29, Comparing Mean and Median Part 2. How can we compare the mean and median of data sets? For the introduction, students are provided a hypothetical height data for their class in centimeters. They are asked, what do you notice? What do you wonder? To support students with disabilities, provide them with sentence starters such as, I notice blank, I wonder blank. You can let them know that they will not be penalized for grammar or spelling so that they can focus on their noticings and wonderings. For the Explore, slide B was split into 2 parts so that students with disabilities are not overwhelmed with 2 questions on one slide. B1 asks, find the mean height of your class in centimeters. To support students with disabilities, provide them extra processing time, especially since they will need to calculate the mean of 36 numbers. Also allow them the use of a calculator to minimize any calculation errors that may occur during this process. So students will get that all of the data points combined will get them 6,056. And as previously mentioned, there are 36 data points, so they will be dividing by 36. Let them know that they should round to the nearest whole centimeter. So students will get that the mean is approximately 168 centimeters. For slide B2, students are asked to find the median height in centimeters and to show their reasoning. To support students with disabilities on this slide, you can provide them with a list of the data points in order. So it would be 151, 153, 158, 159, 160, 160, 160, 160, 161, 161, 162, 162, 163, 163, 164, 165, 166, 167, 168, 168, 170, 171, 171, 171, 172, 173, 175, 177, 177, 178, 178, 179, 179, 184, 185, 185. When students find the median, it will be between 167 and 168, which means that the average of those two numbers is 167.5 centimeters. For slide C1, students are asked, suppose that the world's tallest adult, who is 251 centimeters tall, joined your class. Think about the following and explain your reasoning. How would the mean height of the class change? So for this slide, students are not calculating that mean. Have them focus on how they think the mean would change. So students should be able to articulate that the mean would increase due to this outlier. For slide C2, given the same situation, how would the median height change? Students should be able to articulate that the median will not be greatly affected due to the addition of the world's tallest adult. For slide D, they are going to find the new mean and the new median given the height of the world's tallest adult of 251 centimeters. They can add 656 and 251 in the numerator and 36 plus one more data point to the denominator. So they would get 6,307 over 37, which gets them approximately 170 centimeters if we're rounding to the nearest whole number. And their new median should be 168 centimeters. An anticipated misconception for this slide and slide G is that when calculating the mean after a new person joined the class, some students might enter all the individual heights into a calculator once again, rather than using the sum from their original mean calculation to save time, as shown on the slide here. Urge students to think about how they might use the previous calculation to make the process more efficient. On slide E, students are asked which measure of center, the mean or the median, changed more when this new person joined the class. Explain why the value of one measure changed more than the other. A sample response would be that the mean changed more than the median when the new student was added. This is because the very large value of 251 is far from the center. It pulled the average and the balance point up quite a bit. The median did not change very much because the middle value is simply the next point in the data set, or the average of the two middle data points. And in this case, it was just the next data point. For slide F, students are asked, the world's smallest adult is 63 centimeters tall. Suppose that the world's tallest and smallest adults both joined your class. Think and explain your reasoning. How would the mean height of the class change from the original mean? How would the median height change from the original median? Students might say, since the small value is also far from the center, it may pull it back closer to the original mean, or students can say that it could pull the mean farther down than when the world's tallest adult was added. For the median, students will say that it won't change as much since another data point was added. Students are now going to find the new mean with the world's tallest adult and the world's shortest adult. Students can simply add 63 to 6,307, and they can add 1 to 37 since that's how we found the previous mean, and they would get 6,370 over 38, which gets them approximately 167.6 centimeters. Students will notice that the new median remains at the original median, which was 167.5 centimeters. For slide H, how did the measures of center, the mean and the median, change when these two people joined the class? Explain why the values of the mean and median changed the way they did. A sample response would be, the new mean is a little higher than the original mean, and the median is unchanged. This is because the height difference between the world's tallest person and the original mean is larger than the difference between the world's smallest person and the original mean. So the new center or balance point is pulled toward the higher end. The median is not changed because a new data point was added on each end, so the original middle value is also the new middle value. For slide I, students are going to use these whole class discussion questions to further explore how unusually high or low values affect the mean and the median. Invite several students to share the new mean and median and to explain how these measures would change if the world's shortest person joined the class. The questions include, what effect does the smallest person in the world have on the mean? Why? Which would affect the mean more, the height of the tallest person or the height of the smallest person? Why? Suppose a new student who has a height close to the mean joined the class. Would his or her height affect the mean? Why or why not? Does adding two values, one unusually high and one unusually low, affect the median? Why or why not? Students should see, regardless of which question point, is that adding a data point to each end does not change the median much, if at all. The original middle value would still be the middle value if the halfway point is unchanged. Conversely, the mean would change greatly due to values that are extremely greater or less than most of the data. For the summary, students are recording their response to the focus question, how can we compare the mean and median of data sets? You can provide students with a sentence starter as shown on this slide. If students are struggling, please direct them to this support video. For additional practice, students can complete the Open Up practice problems, IXL 6th grade HH.5, changes in mean, median, mode, and range, or Khan Academy, effects of shifting, adding, and removing a data point. This lesson was adapted utilizing Illustrative Mathematics and Open Up resources. Please visit these sites to support digital learning. If you have any questions, reach out to a virtual content specialist. Thank you.